Hi students, good morning to all of you. Today we are going to discuss about an excellent trick to find bond order, bond stability, bond length and magnetic property of different covalent molecules and ions. Let's start. Here I am giving first in a molecule or a ion total number of electrons. From that how to find bond order, I will give you a trick, right? See, now first I am giving total number of electrons in a molecule. It may be 14, 13, 12, 11, 10, 9, 8. Next 15, 16, 17, 18, 19, 20. Next remaining things 1 to 7. Here this 9, 19 odd number of electrons, right? So that is 1, 3, 5, 7. Next here 2, 1, 2, 3. Next here 4. Next here 6. See 1, 2, 3, 4, 5, 6, 7, 8 remaining, right? These are all what, my dear students? These are nothing but total number of electrons in a molecule or a ion, right? If you know total number of electrons in a molecule or ion, from this value, from this number, total number of electrons, we can find out bond order. We can find out bond order, right? So then bond order is equal to what? That is, if the molecule or ion having 14 electrons, then bond order is 3. The molecule or ion having 13 or 15 electrons, bond order is 2.5. 12 or 16 electrons, 2.0. 11 or 17 electrons, that is 1.5. Then the molecule have 2 or 6 or 10 or 18 electrons, the bond order is 1.0. The molecule having 1, 3 or 5 or 7 or 9 or 19 electrons, bond order is 0.5. The molecule or ion having 4 or 8 or 20 electrons, bond order is 0. Right? That's it, my dear students. Okay. Now, from this we can find out for different molecules. We'll do now. And see, for example, the molecules are N2. They will give N2 plus. Okay, N2 minus, then N2 2 minus. They will ask increasing order of bond order or bond stability or bond length, right? How to do it? First of all, you have to know number of electrons. You know that is here N2 14 electrons. One nitrogen is 7 electrons. 2 nitrogens are combined, so 14 electrons. N2 plus means 14 minus 1, that is 13 electrons. Here 15 electrons. And here 15, 14, 15, 16 electrons, right? Next one. Now bond order. These are electrons, right? These are total number of electrons. Then bond order. If 14 electrons means bond order 3. 13 electrons or 15 electrons, bond order is 13 electrons, 2.5. 15 electrons also 2.5. 16 electrons, 2.0, right? Then bond order or bond stability, bond order or bond stability, increasing order or decreasing order. If they are, or if the framing of question says, so decreasing order or increasing order of bond stability or bond order, right? So in this case, check it here, which one? Highest bond order. You have to write one small thing, that is, there is a note. What is the significance of bond order? Bond order, if you know, from that we came to know the bond stability of the molecule, bond length of the molecule and magnetic property of the molecule, magnetic property, right? So that means here, generally if bond order is 0, then the molecule does not exist. The molecule does not exist. The molecule does not exist, right? Next one. The molecule, okay, if the molecule bond order 0 means does not exist. The bond order is positive value. Maybe it may be like 1, 2, 3, or it may be fractional value also, or it may be fractional value also, right? Then in these cases, then the molecule is existed. The molecule is existed. Okay. Then higher the bond order is very high. Bond order is high means the molecule has high stability. High stability. Bond stability is more. Bond stability, high stability, and less bond length. Less bond length. Right? Okay, I'll give one simple relationship, my dear students. The relationship is here. The simple relationship you have to keep in our mind. Keep in our mind, that is, if bond order is directly proportional to bond stability, it is directly proportional to bond energy, it is directly proportional to bond angle, all are inversely proportional to bond length. Okay. So this one you have to keep in our mind. This one you have to keep in our mind. Right. Yeah. If the molecule have more stable, then bond energy is more, bond order is more, bond angle is more, but bond length is less. If bond length is less means then the molecule is a highly stable molecule, more stable molecule. Right? Got it. Now here, among this, which one have highest bond order? 3, that is for N2. So that's why you get the order is N2 is greater than. Next, in these two cases, N2 plus N2 minus, both have same bond order, right? If bond order is same, then how can you decide which is more stable is? During the filling of electrons into various molecular orbitals, if the electrons are present in the anti-bonding molecular orbital causes destabilization. It does not favor for bond formation. That's why the molecule is less stable, right? So that's why here in the N2 minus, it have anti-bonding molecular orbital is present. Anti-bonding molecular orbital, right? So that's why it is less stable. It is less stable. If you write electronic configuration, you will get it. That is then, and so that's why of these two, it is anti-bonding molecular orbitals. Or then electrons are present in the anti-bonding molecular orbitals. If electron is present in the anti-bonding molecular orbital, then that molecule is less stable, right? So that's why. So which is more stable in this out of these two? N2 plus. N2 plus. Next one is N2 minus. Okay, because 2.5. Next N2 2 minus. N2 2 minus. Got it? And if they ask what is the bond length order? Bond length means that is it is inverse opposite, right? That is N2 is less than N2 plus is less than N2 minus is less than N2 2 minus. Okay, is it clear? Next one. One more, another molecule. Generally they frame the questions from this one also. That is O2 plus O2 minus and O2 2 minus. Right. Oxygen. So oxygen cation, and it is a peroxide and a superoxide. Right. You have to find out first number of electrons. You know, in oxygen, how many electrons are there? One oxygen is 8 and two oxygen atoms, that is 16 electrons. And O2 plus 15 electrons. And O2 minus 17 electrons. O2 2 minus 18 electrons. Right. Now, what is the bond order value? This is the total number of electrons. Right. Then bond order value. Okay. So bond order, what is the 16 means bond order, what is the trick? That is 2.0. 15 means bond order 2.5. Okay. And it is 17 electrons means 1.5. 18 electrons means 1.0. Okay. Then you come to know, then what is the order? So order of bond stability. Okay. So which is highly stable, which one having high bond order is high. If bond order value is very high and that molecule is high stable molecule and less bond length. Okay. So this relationship I gave here. Got it. So that's why here bond order is high, bond stability is more. Which one is highest bond order? That is O2 plus, that is 2.5. Next O2, next O2 minus, next O2 2 minus. Next one, what is the order of bond length? It is opposite. O2 plus is less than O2, is less than O2 minus, is less than O2 2 minus. Got it? Is it clear, my dear students? Okay. Okay. Next one. Next one. Some other molecules. Do for example, hydrogen, H2 molecule, H2 plus and H2 minus. Okay. So what is the bond order for these molecules, my dear students? What is the bond order for these molecules? Right. Tell me now. H2, how many electrons are there, my dear students? H2, how many electrons are there? There is one hydrogen is 1 electron, 2 electrons. H2 plus 1 electron. H2 minus 3 electrons. Then what is the bond order? Tell me now. So 2 electrons are there. 2 electrons are there. Then the bond order is 1. Bond order is 1. 1 electron is there. Bond order is 0.5. 3 electrons are there. Bond order is 0.5. Okay. Got it? Okay. So here, generally keep in our mind, whenever positive charge, cation is there bond strength is more, bond order is more. Right. So bond strength, see here O2 plus, O2 2 minus. So it is cation, bond strength is more and it is less. Okay. This is O2 plus, O2 minus. And here also, so check it here, N2 plus, N2 minus. So both have same bond order, but because here electron is there in the antibody molecular orbitals, so that's why it is more, it is less stable. But N2 plus, so it is more stable. So positive cation is there, so size is smaller, cation. So that's why it is attraction is more, stability is more, bond strength is more. Okay, N2 plus cation, bond strength is more, N2 minus, bond strength is less. Right. Next one. For example, they will ask what is the bond order of helium molecule? Helium, He2. He2. So in helium, how many electrons are there? One helium is 2 electrons, and 2 helium there is 4 electrons. If 4 electrons are there, what is the bond order? 0. So bond order 0. Bond order 0 means the molecule does not exist. So that's why He2 does not exist. He2 does not exist. The same thing you can find out for B2, beryllium. Oh, sorry, boron. One boron have how many electrons? 5. 2 borons, 10 electrons. If 10 electrons are there, so 10 electrons are there. What is the bond order? 1. Bond order is 1. And you take B2 molecule, B2, beryllium. So beryllium, one beryllium, how many electrons? 4. Hydrogen, helium, lithium, beryllium. 2 beryllium, 8 electrons. 8 electrons means bond order is 0. That means it is also not existed. So B2 not existed. You may get the question, why B2 not existed? Because bond order is 0. He2 not exist because bond order is 0. It is inert gas. So bond order is 0 indicates there is no bond present between the two atoms. Got it? You know, bond order, if you calculate, one formula is there. So instead of that formula, you have to do this one. So what is the bond order formula that is? So bond order formula is, bond order is equal to number of electrons present in the bonding molecular orbitals minus number of electrons in the antibonding by 2. That is half of the difference between the electrons present in bonding molecular orbitals to that of electrons present in antibonding. Right. So there is also nothing but number of bonds present between the two atoms. So in case of N2, maximum bond order is 3. Okay. So bond order 3 indicates between two nitrogen atoms there are 3 bonds are present. In O2, bond order is 2. That indicates between two oxygen atoms bond order there is 2 covalent bonds are present. Got it, my dear friends? Okay. I think you enjoyed my video. Yes. Then in the next video, regarding this bond order, some resonance structure molecules are there. Like a carbonate ion, a sulfate ion, a phosphate ion, a perchlorate ion, and ozone and benzene. So how to calculate bond order for resonance structure molecules? One small tricks are there. No need to know the draw the resonance structures. If you don't know, then it is very easy to do it. Some trick will give to you. You just watch that video also, right? So I think you enjoyed my video. Like it, subscribe it, and share to your friends. Thanks for watching my video. Fine.